Every bridge you cross, every floor you stand upon, all of them held up by a silent hero, the beam. But a beam is only as strong as our understanding of the forces upon it. Welcome to Beam Statics. In part 1, we master what a beam truly is and the 4 loads it must carry. So, what is beam statics? A beam is a slender member, its length far greater than its depth, built to carry loads across a span and to resist bending. Beam statics is the discipline of holding that beam in perfect static equilibrium. Every force and every moment must balance. The sum of horizontal force is 0, the sum of vertical force is 0, the sum of moments 0, and when we cut the beam, 3 internal actions are revealed: axial force, shear force, and bending moment. But before we can find them, we must first master the loads that cause them. First, the point load. A single concentrated force striking the beam at one location, we call it P, measured in kilonewtons. A person standing on a bridge, a column resting on a beam, we draw it as one bold arrow. Simple yet powerful. A point load both shears the beam and bends it. Consider a simply supported beam 6 meters long, carrying 20 kilonewtons at its center. Since the load sits at the middle, the two reactions are equal. Each support carries 10 kilonewtons. Next, the uniformly distributed load. Its symbol W. This load does not strike a single point. It spreads evenly across the beam with constant intensity measured in kilonewtons per meter. The weight of a brick wall, a floor slab, the beam's own self-weight. And here is the secret: a distributed load can be replaced by a single equivalent load. P equals W times L, acting at the midpoint. Take 5 kilonewtons per meter over 6 meters. The equivalent load is 30 kilonewtons, acting at the center. And because it is symmetric, each support carries 15 kilonewtons. Now, a load that changes, the uniformly varying load. Its intensity rises linearly along the beam, 0 at one end, maximum at the other, forming a triangle. Picture water pressure against a dam growing with depth, or earth pressing on a retaining wall. Its equivalent load is W times L divided by 2, and it acts not at the center but at 1/3 from the heavy end. Take a load rising from 0 to 12 kilonewtons per meter over 6 meters. The resultant is 36 kilonewtons, acting 2 meters from the heavy end or 4 meters from the zero end. And finally, the applied moment, also called a couple. Picture two forces equal in size but opposite in direction, acting parallel to one another a small distance apart. Because they are equal and opposite, they cancel. The net force is 0. The beam is not pushed. And yet together these two forces produce a pure turning effect. A rotation, that turning effect, is the moment. Its magnitude depends on the force and on the perpendicular distance between them. M equals F times D, measured in kilonewton meters. Think of your hand upon a steering wheel or a spanner turning a nut. For example, two forces of 10 kilonewtons acting half a meter apart create a couple of 5 kilonewton meters. 4 loads: the point load, the distributed load, the varying load, and the moment. Master these, and you hold the foundation of all beam analysis. Next, in part 2, we balance the beam and find its support reactions. Then in part 3, we draw the shear force and bending moment diagrams. Subscribe and hit the bell. And for MCQ practice, follow our Telegram channel, Learn Civil Easy. The link is on your screen. This is Beam Statics.